Hey guys, I'm back with a new series. In this series, we will be learning about React hooks. Back in 2013, when React was introduced, a lot of the exact same principles that we use today existed then as well, namely the things like state, props, and composition. The only thing that has changed are some of the APIs, which we will discuss in this video and the subsequent ones. So in this video, we will start to learn about various React hooks. So without a further ado, let's get started with our very first hook, which is useState. Now this is the first of the many hooks that we will be covering in this series. So let us first understand the syntax for useState. So the very first step is to import the useState hook from React. useState, as you can see here, takes on a single argument, the initial state or the initial value, and gives us an array with the first item being the piece of state and the second item being the handler to set that piece of state. The second item is also known as the state updating function. So here we are using array destructuring to grab the first item, which is the state value, and the second item, which is our state updating function, to change this piece of state. Make sense? So let us take an example to understand this. So with the useState hook, we are able to solve the problem of adding a state to the functional components. The next problem that React hooks solve is the way to add lifecycles. So let us understand why we need them. So to understand this, we need to first dive a bit into how we use to define the lifecycle methods in class-based components. Now here you can see the section adding lifecycle methods to a class. So for example, you can use these hooks component did mount and component will unmount. So component did mount, for this example, as you can see, it says it sets up a timer when the clock is rendered to the DOM for the first time. So it is called mounting in React, and unmounting when you want to clear some timer or any subscription for that matter. So whenever the DOM produced by clock is removed. So with React hooks, what we can do is, what React hooks does is that all of these lifecycle methods can be clubbed under a special React hook that we can use with functional components for adding lifecycle to our functional components. So this special hook is the useEffect hook. So the useEffect hook lets you perform side effects from your functional components. So this is typically what we used to do with the lifecycle methods that we had in class-based components. So the useEffect hook takes in exactly two arguments, a function and an optional array. So it is inside this function that we define which side effect to run. The optional array is what we call as the list of dependencies. So in essence, if any dependency that we specify in this list of dependencies changes, it causes the effect that we define in the callback function to rerun. Make sense? So now we know a bit about these hooks, and these are the most basic ones that you would need in pretty much every React app that you build. Now the useState hook, as we just learned, provides the ability to own and manage the state in functional components. So in essence, with the advent of React hooks, we no longer need to use classes as stateful components. We can plug the useState hook into a functional component and turn it from dumb to smart, which was not possible before the introduction of hooks. Now let us see a very simple example of the useState hook. So back to code sandbox. So here I have already defined an example. So we have our app component, and inside here we are nesting our learning state component. Now this learning state component, as you can see, is a functional component that uses the useState hook, and this component manages a single state, which is the BG color. Now as a default color, I am using the red color. Also we have two buttons. So on the click of the first button, which is this button, which says turn green, it changes the background color of the div to green. So let us click on this. Okay, so our second button also popped up in the DOM, which is because of this condition that if our BG color is green, then render this button which says reset. So if our current background color is not red, then this button will show up, and if we click on reset, then this resets our color back to what it originally was, which is red. So on the reset, we are calling the state updating function and passing the red color to it. So in essence, we are calling our state updating function in both the cases to change the background color, and this does two things. So these state updating functions, the setBGColor, it causes a change in state. Now this change in state causes a re-render, and hence we get our new UI. So with the useState hook, we are able to preserve the values between renders and trigger a re-render of the component. So whenever a re-render happens, React is going to rerun the function learning state, and we are going to get a new UI based on this new state. So no matter how many times your function reevaluates, the useState hook would preserve the values between re-renders. So these values are not garbage collected as you would normally expect for normal variables that we define in a function. This state value that we have defined using the useState hook is managed by React. So it implicitly preserves the values for the BG color between re-renders. Make sense? Now let us talk about functional updates with useState. Now back to our second example, which is a counter example. So here you can see we are having two functions, increment counter and decrement counter, and the counter piece of state, which we are managing using the useState hook. And here we have two buttons, one for incrementing the counter, another one for decrementing it. So if I click on increment counter, this changes the value of counter by 10 steps because we are having this for loop. Now the interesting thing here is that we are depending on the previous value of counter to get the new value of counter. So each time this button which says increment counter gets clicked, this makes the for loop to execute. So when the button which says increment counter gets clicked, the increment counter function runs. Now here we are having 10 calls for the setCounter state updating function. So what React does under the hood is that it schedules these state updating function calls and batches them. So these 10 calls are batched into one. So the counter value changes from 0 to 10, and once this is done, it re-renders the entire component and reflects the value of 10 in the UI. Now instead of this, if I comment this out and say set counter plus 1, and then again copy this and paste it like this. So here we are having 4 calls for the state updating function. Let us try this out. So now if I click on increment counter, you can see we only get 1. So what is the reason here? The reason here is that in this case, React doesn't batch these state updating function calls. So when the increment counter function runs and we are on this line which says set counter plus 1, so this line gets scheduled and this causes a re-render of the component. The value gets reflected as 1 in the UI, and these calls do not take place at all, right? So if your current state value depends on the previous value of your state, then always use this functional form, right? So in the functional form, you pass a callback function to the state updating function, which receives the previous value of the state, and based on that previous value of state, you generate your next state. Make sense? Now for decrement counter, if I click on this, turns the value from 1 to 0. Again click on this. This works. Now here also we are using the functional form. So if I replicate this multiple times and then give this a whirl, let us click on decrement counter. So you can see it gives us the correct value of -3, right? Because React batches these state updating function calls when you are using the functional form of the state updating function. And here we are using this because these state updating function calls are asynchronous in nature. So to always get the correct value for the state, it is recommended to use the functional form when your state value depends on the previous value of your state, right? So this is it for the useState hook that I wanted to cover. Let us move forward to the useEffect hook in the very next one.